Hey guys, I just wanted to make a video about a homework problem. This is a FlipItPhysics homework problem in the section Sound, Energy, and Matter, and it's homework problem number 10. So the problem starts out saying a signal of 1 times 10 to the negative 4th watts is sent from an ultrasound probe at the surface of a patient's body. It is desired that the return signal be no less than 10.6 watts per meter squared in intensity when it is received by the probe. The signal will reflect off the object with an area of 2 centimeters in diameter. How deep within the body can this object be for the return intensity to be the necessary level? Assumption: sound wave will propagate spherically from the ultrasound from the object, and from the object they are reflected. There is no attenuation, and all of the sound is reflected. So see, we have the picture here of the probe. We have the waves going out spherically, and then we have the waves coming back out spherically from the device. So this is what we're given. We're given an initial power, which is 1 times 10 to the negative 4th watts. We're given an intensity out, which we need. That's the necessary level that we're not trying to find, but it's just given to us. And then we have a diameter of the object, which is 2 centimeters, which I converted already to meters. So there's the diameter of the object. And then we have an area. We can also find the area from that object, which is 4 pi d divided by 2 squared. And I already computed that for later calculations. So it's 3.14 times 10 to the negative 4th. So what we're trying to find is the depth at which we can have that return intensity. So there's 3 phases in this problem to consider. So I'll go ahead and show the equations here. So in the first equation, we have initial power that is given, which results in some intensity, which is not given, which is incident upon the object at a distance r. And that's not given. And this is what we are trying to find. We're trying to find the r value of how deep the object is. So then we have another phase of this problem. We have the intensity is collected on the surface of the objects, which we find the area of through the diameter that's given. We assume that all of the power that reaches the surface of the object is reflected back, since there's no attenuation. And then we have the third phase, which the reflected power provided back at this, the reflected power provides intensity back at the surface given, that is a distance r away. So we're left with these 3 phases, and we need to manipulate them around, because in each equation we have one known. So we have the power initial here, we have the area that we found through the diameter, and here we have the intensity out. There's a few different ways you can do the algebra to find the r radius that we're trying to find, and we can find it here too. So you can set these i's equal, and then take this power reflected and plug it into there. But I found that algebra to be a little bit messy, so I'll go ahead and show you how I did my algebra. So find r to depth. We have those 3 phases, and we're going to manipulate them around with algebra to isolate r. So manipulate equations to find the unknown r. So at first I used equation 2, and I took the I in equation 2 and I replaced it with equation 1. So I replaced it right there. So then we have P reflected equals P naught times area divided by 4 pi r squared. Then I took equation 3, I out equals P reflected divided by 4 pi r squared. And I split it apart to make the algebra a little bit easier. So I pulled the PR out as a separate, and I replaced it with the PR that we just found right here. So this is then be put in place of PR right here. So now we are left with an equation. I out equals P initial times area divided by 16 pi squared r to the fourth. And that's because I multiplied all those together. So r is the only unknown, and now we can isolate r. So this is just algebra, manipulating things around. I multiplied the I out by the denominator, and then I took everything but the r to the fourth, and I divided it by the P naught area. Then I took the fourth root, and I'm left with our final equation that we would like to solve. So I plugged in all of our known values, and our final answer is 0.1187 meters. I hope that helps. Thanks, guys. Bye.